Hi, and welcome to SDC India 2020. I'm Richelle Ahlvers of Intel, chair of the SNIA Scalable Storage Management Technical Work Group, or SSM TWIG, and a member of the SNIA Board of Directors. The SSM TWIG is the group that develops the SNIA Swordfish specification. I hope you've had a chance to already watch the SNIA Swordfish overview and deep dive. If not, please take an opportunity to go review that presentation when you're done with this one. A quick disclaimer: information in this presentation represents a snapshot of work in progress within SNIA and is subject to change without notice. All of the information I cover today will be able to find from snia.org/swordfish. And I would recommend you keep an eye on this URL. I will review it a couple of times today, but this is a very important one to remember, and is where you can find pretty much all things swordfish. So here's a little overview of what we're going to cover today. There's a lot of stuff that's happened in 2020. A lot of things we've added to Swordfish and to the Swordfish ecosystem. So that's largely what I'm going to talk about in this presentation, but there's been a lot of stuff. We've added a lot of new functionality in the latest version of Swordfish. We'll talk about what that looks like and also about what we've added to the Redfish ecosystem. We've added a bunch of new schema enhancements and simplifications, including moving/storage to the service route. I'll describe what that looks like for you. One of the key things we've done this year, we spent a lot of time on, is adding support to map NVMe and NVMe-oF. Those are the specifications as developed by the NVM Express organization, mapping those to Redfish and Swordfish. We've also done really a lot to work on the ecosystem, helping to accelerate implementation. So there's a bunch of new documents. We'll talk about what those are and what they're used for. We've also working on adding Swordfish to the set of standards that SNIA has pushed through ISO. Swordfish, we'll talk about the timeline for that we expect to see the Swordfish specification available as an ISO spec. There's a lot of new mockups on our mockup site, swordfishmockups.com. I'll talk about what those are. And then a lot of enhancements as well in our open source tools ecosystem. So I'll talk a little bit about those, but there's also some other presentations I will point you to that you can find a lot more details about those. And last but not least, some new supporting programs in our Swordfish ecosystem. The Storage Management Initiative has put out a new program called the Swordfish Conformance Test Program, which we'll talk about. If you're familiar with the SNIA Conformance Test Program, you've got a leg up here, but we'll describe that for you as well. There's a lot of new Swordfish functionality that we've delivered in 2020. First, we've simplified for the clients by adding /storage at the service route as a required function. So there's support for those in both the schema and in the latest version of the profiles. We'll talk about that and about why that's important in just a little bit. I've also added, again, as we noted, a lot of functionality pervasively for NVMe and NVMe-oF fabrics, not just in Swordfish, but also in Redfish. You'll find enhancements in both the Redfish and Swordfish schema. You'll find mockups at not just at swordfishmockups.com, but also on the DMTF side. There's also a new documentation in a couple of different forms. We've got a new NVMe specific document, the Swordfish NVMe model overview and mapping guide. This is a really comprehensive document that describes both the overall model for how to represent NVMe devices in Redfish and Swordfish, as well as the mapping between the two different sets of specifications, treating Redfish and Swordfish as one, and then NVMe and NVMe-oF as the other. And I'll describe that and how that works in a little bit. We've also added a bunch of NVMe use cases to the Swordfish Users Guide. What this really does is allows folks who are NVMe literate that may not be Swordfish literate yet, from a client perspective, to start to see some of that terminology and how that's going to actually be applied. So, for example, someone who might be thinking, okay, I know how to create a namespace. What does that look like? They'll actually start to see some of that terminology populate into the environment for them. Some of the other changes are really a little bit more classic and are based on implementation feedback and enhancement requests we've gotten. And so these just are, enhancing functionality in volume and storage pools in storage groups within Swordfish. Talking a little bit about storage at the service root. What is that for? Why is it there? From storage version 1.2.0 on, the clients will always be able to find storage instances in Redfish v1 storage. That's a collection that sits at the service root. Why is that important? Well, what that does is it simplifies the search and system traversal for any client. You will always be able to find instances of storage at that collection. I will show you in the next 2 slides a couple of different implementation options, and just to kind of highlight why this is important and how this simplifies things for a client perspective. In this first example, this is what we call, a Swordfish standalone configuration. This could be something like a disk array. So the implementation would be created with, /redfish/v1/storage, and then there's a singleton instance here and a bunch of, subordinate resources. Featured registry says here's the functions that are implemented there. So in this case, the user has no issue. They could just go to /redfish/v1/storage and find the devices. Great, no problem. However, there's a lot of other types of potential places you could have attach your storage. Your storage could be attached in a system. So you have a computer system with storage attached to it. And in this case, what it would look like is I have /redfish/v1/systems /storage. And so in today's environment, or the pre-v1.2, then the client has to basically traverse the environment and say, where are all the instances of storage? Are they under systems? Are they in composable systems? Where are they? Because this is just a couple of examples. There's actually multiple locations where they could be. So by saying, no, you also have to put, like in this case, you can see the storage is actually over here under /system/storage. But what you're doing is you're putting a link to the instance in /redfish/v1/storage. The client can always go to /redfish/v1/storage to find the instance. So if we combined the 2 examples we just saw, you could find both different kinds of systems in that same collection. Okay, so let's move on to NVMe and NVMe over fabrics and talk a little bit about what we've done, why we've done it, and a little bit about the scope here. What we've done here is we call it a mapping, and let me just describe what that is and a little bit about the scope here. So this has really been a joint effort between SNIA, DMTF, and NVM Express that's been hosted within the SSM twig. This is not creating new specifications. What this is doing is taking existing specs and mapping them together because they sit in different places in the overall ecosystem. NVMe, NVMe-oF, NVMe-mi specs really talk about how you manage individual NVMe devices and how you interact with them at a very low level. Redfish and Swordfish are about how do I manage devices and systems in either at a system level, at a data center level, at an enterprise level. It's really a much higher level. It doesn't actually talk at all how you get that information out of a device. So what the mapping does is basically take those 2 different perspectives and put them together. So you're able to basically manage NVMe and NVMe over fabrics in the context of a much broader scale system in Redfish and Swordfish. So Swordfish gives you the storage perspective, and Redfish gives you systems and fabrics and networks and allows you to put together the entire ecosystem. On the NVMe side, you also have a very broad scope. We took basically NVMe subsystems, NVMe over fabrics, and the new NVMe domain models. So you've got a very, very broad scope of the NVMe environments as well. Our approach here was really to basically reflect a unified view of all the NVMe device types in a single model. When you go to create a specific type, or device type, you instantiate the appropriate subset of the model. Our diagrams are not intended to reflect all the available schema elements. They're really focused on the logical models that we're trying to map here. The other tenet we tried to follow was basically trying to coarsely map the NVM subsystem model to the existing storage model, so that from a client perspective, there was consistency from legacy and alternate technology devices. So from things they know to kind of switching into an NVMe world. So those are kind of some of the promises that we worked with. The full details are again in the model overview and mapping guide. So the main things we worked on were really these set of NVM objects: subsystems, controllers, namespaces, endurance groups, and sets and domains, and mapped those concepts over. What does that mapping look like? So what we really did here was we looked at, and going with that one of those last tenets that I talked about, we started with looking at both the high-level models on each side and saying, what do they really look like? Let me just talk a little bit about what the existing storage model looks like. It's very high-level conceptual, so you'll recognize this. If you think about what a storage system fundamentally looks like, you've got a storage subsystem, and then some semblance of controllers inside that. From that, you have the ability to carve out pools of storage from which you can allocate volumes, or file systems, or objects. In this picture, we're talking purely about blocks, so you'll see the file systems. But that's the conceptual model that we have within Redfish and Swordfish. Redfish uses a very simplified view of that and does not reflect the Swordfish elements of pools. It basically says, I have storage and controllers that can create volumes. Okay, and the other side, the extended side of that is I have a physical representation that's a drive. Basically says there's a drive object. For other types of things, there's other types of, they're coarsely called chassis. The chassis model is the physical model. So, there's drive is basically a type of chassis. Think of it that way. Okay, so if we switch a little bit and think about from an NVMe perspective, the NVMe, NVMe-oF specifications have a hierarchy as well. So you have this thing called an NVMe subsystem. You have these things called controllers. These are all logical controllers. They're not really the same thing, but they have this notion. So you have these different types of controllers. And then you have these things that basically function as groups or pools, sets or pools, but they're basically things that you can carve capacity out of. And then and they're hierarchical. So you can have a group that is a type of object that you can carve capacity out of with some set of attributes. A set is similarly same kind of thing. And then you get to the bottom and you have the things you can, a chunk of capacity that you've created, which is, so a namespace is analogous to a volume. And if you look at it, step back and look at it from a very high level perspective, that maps rather well to our existing model. Now, there's some fundamental differences when you get into it, that on an existing storage system, these controllers tend to be very physical. And in NVMe, these are very logical things. They're not really quite the same thing. But from a high level model perspective, this is a very good mapping. So that's what we've done here. So that's probably no detail there. What we really did in order to make this all work and to validate what we've done is we worked through a bunch of mapping models and documented the permutations. And we've also, as part of that, we're able to basically we created mockups, we created diagrams, we created also use that as a way to basically come through with the first pass of all of the, or a first set of all the properties to use for all these different permutations. So let me just talk through a little bit of this, and I'll walk through again how this mapping worked. So what you can see here, this is for a simple SSD. We say default endurance group and set, which really means there isn't one. That's a nuance, an NVMe nuance I won't get into. But what you've got is this reflects a lot of the NVMe SSDs that exist today, where when you look at what they've implemented, they have a subsystem, they have largely generally one I/O controller, one namespace, although some are capable of more, but these are largely 111. And then that's what's in this coming from the specs. This other stuff over here, there's a bunch of other stuff that we call we're calling in this picture a physical element representation. That's information that's outside of those three elements, right? But you have to reflect it somewhere, through information, and the things, well, I don't need to detail all of that for you. So, but you can see how these things map, right? So this physical element is going to map to a bunch of information that's not in the NVMe Express specs themselves, but needs to be there in order to deliver that product. Those things are actually reflected in a standardized way already in Redfish and Swordfish, largely coming from the Redfish specs, again, in that those physical chassis and drive objects. So we've just provided the mapping of what should be there. And that's really, a very clean mapping of how to do that simple SSD. When you go to say, okay, I want to instantiate one of those, a chassis, you end up with a power and thermal instantiation, a drive object, a storage object. In this particular example, and this maps the mockup that's online at swordfishmockups.com. This one is actually a PCIe drive that's attached to a system. So that's actually what you see here. Links, it's actually in this collection, but reflected over in this /redfish/v1 storage so that you can find it. But again, one subsystem, one controller, one namespace, and it's a relatively simple implementation. Another one mock-up we created, another type of system, reflects a JBOF. And so if you're looking at just the JBOF, this corresponds to, a enclosure with management. From the with management portion, that enclosure management portion is not in the spec. So again, that's that yellow portion maps over to that chassis stuff. And that could be done through SCSI enclosure services or something else. But from a Redfish Swordfish perspective, again, it's going to map into standard representation. So you end up with, again, just storage and an admin controller reflected here. Again, then you get, when you want to reflect the entire system, you basically start populating in a number of drives. That's where the namespaces come in, and you just get the combined system. So the bubble diagram basically just gets really busy. But what we've added here is that admin controller for the JBOF. You can see from the JBOF coming up here. It's basically got a storage instance and a controller instance, and that's it for the JBOF, plus the chassis information that's over here. And everything else is basically n number of drives in here. I've kept it to 2 to keep it from getting super busy, but it does get pretty busy. All right. Switching over a little bit and talking about the NVMe-oF model. The fabric model is an entirely logical model that layers on top of the underlying NVMe subsystem model. For the purposes of this discussion, you could say, okay, I see the underlying subsystem model. I'm going to ignore that and just focus on the pieces on the outside. The underlying model here is where the logical NVMe piece sets its resources, right? So this logical subsystem will get resources from this underlying piece. These logical namespaces will come from these pieces here, but we don't really care about that in terms of creating the model. What we do care about is basically keeping these things consistent. On the Swordfish side, Redfish and Swordfish side here, you can see that this model is exactly the same. We've kept subsystem, controller, and namespace. These are the same things. If this model needs to be expanded to include those more complex capabilities, endurance groups, sets, kinds of things. We will add the storage pools here to reflect that and keep the model exactly the same. The Redfish piece of this comes in when we talk about the fabric. What we've done here is basically said this is a fabric model. This is a standard fabric model from Redfish. So we've basically kept it entirely. It's just a standard application of the fabric model. We've actually enhanced it a little bit for some storage specific usage, but not necessarily for a lot of NVMe specific usage. And then you can see basically you've got fabrics with endpoint zones and connections. This actually combines two different things. This combines where the connections and endpoints are used is for, think of it as the storage usage of mapping and masking. And then the fabric zones is for the next layer up under the switch level, if you will, the switch level connectivity. And all of that is reflected over here in the NVMe side. This is the standardization that's coming in the NVMe space around logical or exported subsystems, controllers, namespaces, logical ports, and allowed hosts. So all of the standardization that's being developed in TP 6011, which stands for the technical proposal 6011 in the NVM Express, then gets mapped over to the standard Redfish and Swordfish. And all of that's coming in the mapping document, is detailed in the mapping document or is pending. Domains, very similar. We've just basically gone out and extended on the sides. The NVMe domains are able to be constructed and have a set of rules, so they're able to be constructed the same way, and so that is just entirely mirrored in the Swordfish implementation. Okay, and so we have, one other permutation here within the NVMe-oF space, which is a simple SSD with NVMe-oF, since the technical proposal is still just a technical proposal. So for an SSD with NVMe-oF or IP attached, what we've basically done is that this is how you would implement it. So you've got these basic components for a basic SSD. And then what we do is leverage the standard instrumentation for network adapter, port, device function representation, and model that, and then that is all mapped over to the non-standard instrumentation coming from the device vendor implementation. And again, here's just that model where we've added the Ethernet attached instrumentation. All right, so I mentioned we had a bunch of additional content and documentation, other things like that we've also added to Swordfish this year. We have 2 new documents. We've already talked about one a little bit. There's another one that we've added, the Swordfish Error Handling Guide. So one of the things we've done this year is we've provided a summary of the preferred handling of errors and error messages. This basically looks at a bunch of stuff that's both in the registries and a bunch of things that are options and narrows that down quite a bit. It got targeted as a guide for implementers, both for client and vendors. There's just a bunch of additional guidance there. We've already talked about the NVMe model overview and mapping guide. We've released version 1 of this. We've already identified a bunch of enhancements that we expect to see coming out in 2021. And look for that document to see some significant enhancements as well moving forward. We also talked about new mockups in 2020. Here's just to highlight both of the updated swordfishmockups.com site as well as a list of a bunch of the new mockups that are available out there. We had a bunch of the hosted service configuration mockups. We've now added a bunch of the standalone configuration mockups and integrated configuration mockups, just showing a bunch of the differences there. And cleaning up and simplifying a bunch of those, as well as a lot of those NVMe and NVMe-oF configurations. We will continue to enhance this. If you have your own that you would like to contribute, please feel free to submit those to me or send them to storagemanagement@snia.org. You're already a member company within SNIA or the SSM twig. Please have your primary representative reach out to me and we will get those posted. We'll get them validated and then posted. I also mentioned ISO standardization. The SNIA Swordfish spec has started the process a few months ago to become an ISO spec. After a few fits and starts, it is well into the process. We expect to see process complete sometime in 2021, and we will see we've submitted version 1.1.0 as an international, to be published as an international standard. Once that one's through the cycle, we will look and see what the right timeline is for an update and refresh. I also mentioned an expanded tools ecosystem. We have really been doing a lot to expand the tools ecosystem and the availability for infrastructure and capabilities to accelerate development and validate work. Everything that's available from Redfish works on Swordfish. And some things they have done, we just reference because there's no need for us to build that again. We have built several things, though, that are targeted at Swordfish developers. So one of the things, this first one here, is really targeted at, as a benefit for folks that are in the twig itself. We have an automated and offline build and test infrastructure that will take Swordfish mockups and validate it against the schema. And have been, incrementally more tests being developed as we speak. There are more and more tests being developed. There's also some new open source tools that have been developed this year. In particular, there's one called the Windows PowerShell Toolkit. So if you are Windows developers, and particularly if you're very fond of PowerShell, take a look at this. There's also a couple of presentations online at the SNIA video YouTube channel. You can look at the SDC 2020 tools presentation in the Swordfish track and get a lot more detail on this particular presentation, as well as our tools ecosystem in general. All right. I also mentioned we talk about what is Swordfish CTP and give an overview of where this is. For those that are familiar with the SNIS Conformance test program, you'll see a lot of similarities here to how this program is structured. Swordfish CTP is a vendor-neutral test suite to validate conformance to the SNIA Swordfish specification. It is also a vendor-neutral way to promote and validate your implementations and compliance to the Swordfish CTP test suite. And that is done through participation in the CTP program and publication of your test results, of your validated test results on the SNIA website. The CTP program uses the Redfish spec, the Swordfish spec, and the published Swordfish profiles to determine compliance. These will be done, the compliance will actually be done on a per version basis. So the versioning is done, basically, it'll be published, and you can find this information on the Swordfish CTP website, but it will be done in conjunction with releases of Swordfish that are released as the SNIA standards, which is the new terminology. It used to be a SNIA technical position, but anything that's released, versions that are released as SNIA standard. Again, profiles define required subsets of functionality that implementation can advertise as customer features. So they're groups of functionality. And so each feature then corresponds to key customer functionality. And so that's actually the level of granularity that you can actually validate and publish results against. So where we are, we have the program has been in development. We have the framework, the test infrastructure is in place, and our dev team is building the integration, they've built quite a few tests already, and we are working on integrating and enhancing those tests. We are now working with multiple companies to test the test. Program will be officially rolling out once we have official vendors, results to post. We're kind of keeping it in hardening the test environment at this point. The test environment, however, is also all in open source. It will actually be a lot more lightweight and open than the SNIA CTP program. If you're interested in joining the program or participating in any way, shape, or form, please contact us at storagemanagement@snia.org. As noted, the full program launch is coming soon. All right. Well, I've covered a lot of stuff here, and we would love to have you get involved. If you have things to contribute, please contact us. There's information at snia.org/swordfish. If you have questions, if you have information, if you're not a member of the TWIG, if you're not a member of SNIA, go to swordfishforum.com. If you are a member or if you'd like to join, please check us out at snia.org/members. Or if you're interested in helping to promote the standard and help drive adoption, please come to snia.org/SMI.